Hi everyone. So a lot of you were facing confusion. Let's look at this problem. So what it is telling us is to design a 3-bit non-sequential synchronous, and they've told us to design the circuit using three T flip-flops, and the three flip-flop inputs are T2, T1, T0, where T2 is the MSB and T0 is the LSB, and three flip-flop outputs are Q2, Q1, and Q0, with Q2 mentioned in MSB and Q0 as LSB, right? So what is asked is the input to T0, input to T1, input to T2, which would be fairly evident from the state table if we draw it, and what would be the next state if the counter is in state 3, and is the counter self-correcting. So the first thing in attempting any sequential problem is to figure out this. So here I've drawn the template of how we have to fill this table. So let's start doing it. What we are aware of are the states here, 0, 0, 0. So after we've these are all the possible states using the 3-bit counter. Now the sequence which is told to us is 0, then 2, then 4, then 6, then 0. So if it's in the current state 0, what would be the next state? 2. So for the 2, the value is 0, 1. Then since if I'm at 0, 1, 0, then the next state should be 4, which is 1, 0, 0. So you're right, 1, 0, 0. Now if I'm at 1, 0, 0, the next state should be 6, which should be 1, 1, 0, 1, 1, 0. And if I'm at 1, 1, 0, then the next state should be 0, 0, 0. So rest everything will be a don't care. So now comes the interesting part, that what would be the value of the T flip-flop. So I've written here clearly that for the T flip-flop, the activation table looks like this. So if the transition is happening from 0 to 0, the value of the T flip-flop should remain as 0. If the thing is getting toggled either from 0 to 1 or from 1 to 0, then the value of the T flip-flop should be 1. And if it is remaining the same as from 1 to 1, then the value should be 0. So based on this, I'll fill the diagram. So for the first thing, you can see if it is from 0 to 0, then the value of the T flip-flop, from if the Q2 state is initially 0, then it has to go to 0, then I'll fill here 0. If Q1 is 0, it has to go to 1, then the T1 should be 1. And if Q0 is 0 and it has to go to 0, then this should be 0, right? So if you have drawn the activation table next to you, your thing will be very simple. For the don't care, you actually don't care what is the value. Whatever be it, so be it. Then for, again we look at this from Q2 going from 0 to 1, the T2 value should be 1. For Q1 going from 1 to 0, the T1 should be 1. And for 0 going from 0 to 0, the T0 should be 0. So next, if this is 0 going to don't care, then obviously this is going to be don't care. Then here for 1 going to 1, no toggling is happening, therefore T2 is 0. From 0 to 1, toggle is happening. From 0 to 0, no toggling, therefore 0. So it's 0, 1, 0. Then for don't care, again there is a whole row of don't care. Then for 1, 1, 0, what we'll be doing, again seeing whether the toggling is happening or not. So for 1 to 0, toggling is happening. From 1 to 0, toggling is happening. From 0 to 0, no toggling is happening, therefore 0. So 1, 1, 0. And lastly, again, row of don't care. So now what's the next step? Next step is to figure out, based on this truth table, what should be the values of T2, T1 and T0. I always tell my students to actually, before jumping into K-maps, just try to observe the truth table once. So if you carefully notice, like it's just a puzzle. So T0, you see that 0 don't care, 0 don't care, 0 don't care, 0 don't care. So here the thing is very obvious, like if every don't care is 0, then T0 is, no matter what transition is taking place, T0 will always be 0. So I can simply say, okay, let me put T0 equal to 0. Then if I observe T1, then same thing I can observe. 1 don't care, 1 don't care, 1 don't care, 1 don't care. So I can write T1 as 1. So no matter which transition is happening at what clock cycle, clock edge, T1 will always be 1 for these state transitions which we have drawn here. Now comes the tricky part, T2, because here it's not so simple to observe, but if you think about it, then you see a repeating pattern of 0 don't care, 1 don't care, 0 don't care, 1 don't care. And this looks exactly like, Q1. So you can just as well guess, like, from here that T2 is Q1. So I always recommend looking for patterns like 0001, which refers to an AND gate. So it must be like a AND of some operation. If it's like 0011, 0011, then it definitely means it's the second variable from your truth table. If there is if there are patterns coming like 0110, 0110, then it suggests something like a XOR gate. So you need to keep an eye open of which two variables can be clubbed together, and sometimes, like most of the times, it falls like a usual simple expression. But if you are scared, like, or if you're not able to observe, or I mean, if you want to follow the traditional route, or if the truth table is in itself very complex, which you cannot just simply, like, map from your eye, then better to go for the K map. So let's draw the K map and see. So the first K map, let's draw of T0. So how will this look like? Here we have Q2, Q1, Q0 coming. So I'm writing the gray code 0100, 01, 11, 10, 0, 1, 2, 3, 4, 5, 6, 7. Now if I start in this order, then let me change the color. So I'm filling in 0 right now, T0. So 0 cross, 0 cross, 0 cross, 0 cross. Now, I know that many people are tempted to make a grouping of all the don't cares, but as a suggestion, never group don't cares. If you're in an exam, no one will accept this solution. So never make a grouping of don't cares. And as you can also easily observe that T0 is just 0. So do not club don't cares in any of your exam. The marking will be difficult, but depends from teacher to teacher. But you never group a don't cares. So here the simple thing which is coming forward is T0 is equal to 0. All right. Just like a quick note here, if you fill in 111 here, then T0 will come out to be actually equivalent to 0101, so it will be coming out to be Q0. So in your practical scenario, the things will work, this counter will count the same, but if it's in your exam kind of a scenario, I would recommend not to group your don't cares. So let me quickly draw the other two K maps as well. So pardon me for my bad writing, like I made it really quickly. So I've already filled this one with 1. You can directly keep copying from here. So 1 cross, 1 cross, 1 cross, 1 cross. When it comes to T0, T2, so what you will start doing is 0 cross, 1 cross, then 0 cross, 1 cross. So here, definitely you can make this big grouping, which would, what would it mean? That no matter what, it's always true, correct? This is T1, right? So T1 is always 1. This is what this grouping is going to tell. And for this, you can make this grouping here. So if you make this grouping, then what is common between the adjacent rows? So nothing is common here. In here, what is common? 1, 1 is same, right? So here, T2 will become as Q1. So now if we have taken the value of T2, T1, T0 to be equal to Q1, 1 and 0 respectively, what would the output be looking like? So here, if I've chosen T2 to be Q1, then I know that instead of this don't care, what I need to be writing is as what is the value of Q1. So here it will be 0, here it will be 1, here it will be 0, and here it will be 1. Correct? So for T1, it's always going to be 1, 1, 1, and 1. And for T0, it's going to be 0, 0, 0, 0. So now if in the question it was asked that what would be the next state if the counter is in state 3. So now based on this transition, this T flip-flop inputs, we can figure out the next state. So let's say that if you're in state 3 right now, 0, 1, 1, and the input to the T flip-flops are 1, 1, 0, then this 0 will be toggled because here it is 1, so it will become a 1. Here again it is 1, so this 1 will be toggled, will become a 0, and here it is 0, so this will get copied as it is. Similarly, we'll fill for the other don't care, so it is 0 1 0, so this will get copied as it is, this will get toggled, and this will get copied as it is, 0 1 1. Then for this thing it's 0 1 0, so here, because here it is a 0, this 1 will get copied as it is, here it is 1, so this 0 will get toggled to a 1, and here it is 0, so this will get copied as it is. Here it is 1 1 0, so both of these will get toggled, and this one will get copied as it is. So here you can clearly see that if we are in the state 3 right now, the next state which we would be at is 101, which is state 5. And let's quickly draw the state diagram for this as well. So what we do know is 0 2 4 6 and back to 0. So 0 to 2. So this table we have drawn, so for me it's not very hard to draw this thing right now. Then if I am in state 1, let's say, then I'll be transitioning to, if I'm in state 1, then the next state which I will be going to would be state 3. From this thing you can see. And if I'm in state 3, the next state which I would be going to would be state 5, 101. And if I'm in state 101, the next state which I would be going would be 7. And if I'm at 7, then the next state would be 1. So this is not self-correcting. So the final answers for this question would be, let me change the pen. So input to T0 we saw is 0. Then input to T1 is 1. Input to T2 we saw it as Q1. And what will be the next state? It would be 5, which is given by 101. And is the counter self-correcting? No. So in your exams, do not group don't cares together. Avoid this confusion. But in practicality, if you make a circuit, things will work there. All right. So thank you so much.